Well, let's put all this business about transformation of sinusoidal functions together. So we have learned that we're using cosine this time, cosine B theta minus H plus K. There's our general formula for transformations, where A is the amplitude, B is a transformation of the period, H is a phase shift or horizontal translation, and K is a vertical shift or a vertical translation. So we're asked here to state the amplitude, period, phase shift, and vertical shift for y equals 2 times the cosine of 1/2 theta plus pi over 2 and then minus 2. Well, our amplitude is 2. Our period. Now it's a cosine function, so we start with 360 over the absolute value of b, and b being 1/2, so we got 360 over 1/2. And if we divide by 1/2, that's the same as, we're doing this in radians. I should do this in radians, because I got a radian in the phase shift. So period is 2 pi over the absolute value of b. And then we got 2 pi over 1/2. And if I'm going to divide by 1/2, that's the same as multiplying by 2. So my period is 4 pi. Now we got a phase shift. It says a positive, but I know that means it's really a negative because it's negative h. So the negative negative would yield a positive. And so the phase shift is going to shift it to the left by pi over 2, which if that was in degrees would be 90. And our vertical shift, which is k, is -2. All right, and we're going to go over and graph this thing. Let's think about here a little bit about maybe what our window settings, what we want to put those at based on what we know here. Let's see. Well, we got a phase shift of pi over 2. So maybe I want to start here with an x minimum of -pi, an x max. Let's see. We got 4 pi. That's 2 revolutions around. Maybe I want it to be 5 pi because I want to see both. I could do 4 pi, be fine. My scale, let's do a scale, x scale of pi over 2, since that's my phase shift. Now let's see my y minimum. Ordinarily, my midline would be at 0. Now it's going to be at -1, and then I got an amplitude of 2. I could probably get by with -4, but I think I'm going to use -5. And a y max doesn't have to be very tall, so I'm going to say 3 with a y scale of 1. How about that? All right, let's graph this thing. We'll graph both the parent and the transformation. All right, well, here we are on the calculator. And since I'm doing sinusoidal functions, the first thing I want to do is, do I want to be in radian or degree mode? And if you recall, our phase shift was pi over 2, which means I need to be in radian mode. And I see here that I am, so I'm okay. Now let's go check our window settings. Let's see, I think I wanted, because of that pi over 2, I wanted to have an x min of pi. Because my period was going to be 4 pi, I wanted to use 5 pi, which is in there, and then I wanted a scale of pi over 2, We've got a vertical shift down of 2, so I want to build it with an amplitude of 2. So I'll set this as -5 and 3 with a scale of 1. And you can see here that I graph the parent, and then I entered the parent equation, and then the transformation. Notice here how when I hit cosine, it brings up already a parentheses. Notice how I did the 0.5, the B factor, and then I added another parentheses to get the theta minus h. In this case, it's x plus pi over 2. Had to close the parentheses twice and then -2. So let's go look at the graph of this. So in the blue, that's the parent function. It's fluctuating between 1 and -1. And we have a period of, remember now, each little tick mark's pi over 2. So it needs to be 4 tick marks for the period. So from this high point to this high point on the y-axis, that's 4 units. So that's certainly 2 pi. And then here's our transformation. So we see a shift to the left, -pi over 2. We got an amplitude of 2 with a midline of -2. So we're 2 above in this direction from the midline. We're 2 below this way. And our period should be 4 pi. So to go from this high point to the next, if this is pi over 2, there should be 8 units. So 1, 2, 3, 4, 5, 6, 7, 8. Everything looks just like it's supposed to be. Now, if you can't get excited about this, then you just don't want to be excited. But I want you to be excited. So get excited. Graphing sinusoidal, I have a hard time saying that, functions.